Okay, here we're going to talk about statically indeterminate beams, but we're going to use superposition in order to solve for the reaction. So again, statically indeterminate beam has some redundant support. So what I do is I basically remove it and treat it as a separate load. Okay, so I find that redundant support, treat it as a separate load, use Appendix C where I have all the deflections based on different loadings, along with compatibility equations in order to solve this. So, for example, if I've got a cantilever beam with a roller at the end, I can basically treat that as a cantilever beam with a force in the middle, and then a cantilever beam with the reaction force B at the end point. Okay, then knowing that the deflection at the end point is 0, I can basically set these two deflections equal to one another. Okay, so knowing that compatibility, that boundary condition. Now, I can actually set these up in different ways. I could also treat this as a simply supported beam with a load in the middle and a moment at the end point, because again, my cantilever is both a load as well as a moment. Okay, and then knowing specific things, I can go ahead and calculate that. I can know that the slope at the left side is 0 for this the beam here, so I can set that slope equal to each other to solve for that. But again, the whole idea is you use those redundant supports and treat them as forces, and then break it up into pieces using Appendix C to add compatibility equations for deflection to calculate what you need to. Again, the easiest way to look at this is through an example. So I suggest you go look at the example that I've done using superposition statically indeterminate beams.